Okay, problem 19.8 is a fun one, so I get to do it, and if you want to do it all on your own because it's so much fun, you're welcome to not watch this and check your answer in the back because they have the answers there, but yeah, so here's what's happening. We have a 6-foot long bar, so here's my bar, and I drew the picture again because I want to make it bigger because the one that they drew is kind of small. And we have a point in the bar here, and it's locked onto this point B, right? And this point B is locked onto the x-axis, so it goes back and forth as this point goes around a circle. So it's kind of like a train wheel or something, where you have a point here moving backwards and forwards, making the train wheel go in a circle. So there's two reasons why B will get closer this way, because first, as the point goes up the circle, it's going to pull B over, plus this point is going this way, and that also pulls B over. So it gets, B goes this way for two directions because the bar goes up and also because the bar goes to the left. So it starts off at the point 8, right? When here it's 2 and it's 6 feet long, it's 8. And then when it's way over here, it gets to 6. And meanwhile, it's kind of going back and forth. It gets furthest over here, then it starts coming back. Kind of a complicated motion. And that's pretty much what part A was just talking about doing, kind of saying what we just did. So, hey, we did part A already. All right, let's do part B. B and C say, what are the coordinates of point, or well, B is what are the coordinates of point A as a function of time. We want to know where A is. And what they say is it's going around, point A is just going in our circle at 3 revolutions per second. It's going counterclockwise, which means it's going this way, like we know, which means that it's got a positive omega. So counterclockwise means omega is greater than 0, that we have our omega is positive, so that's nice. And it starts here, they say at t equals 0, it starts here, the normal place to start, which means that theta is 0, the initial angle is 0. So they're making our life easier. They're starting in the right place. So theta is 0, the initial angle is 0, omega is greater than 0, no negative omegas or anything. What we got to do though is, of course, we got to figure out omega from revolutions per second to radians per second. So that's kind of the tricky part here. They didn't make that life easy for us. So let's see, 3 revolutions is 3 circles, and a circle is 2 pi radians. So 1 circle is 2 pi radians per second. So it's 3 times 2 pi radians per second. And they do say revolutions per second, so that's nice. And t in seconds, they didn't give us minutes, so we didn't even have to do the 60 thing. So okay, they're kind of nice. See, 3 times 2 pi is 6 pi. So that's omega, so 6 pi radians per second, so we just know we're dealing in seconds and radians, and that's what our omega is. Okay, right away then we can write down what the x and y is. So x, since, oh, and also we're calling the center 0, 0, so the average is 0. So our x-coordinate is always r, see x is cosine omega t plus theta 0. So in this case the radius is 2, or our circle's 2, so x is equal to 2 cosine theta 0, 0, omega is 6 pi, 2 cosine, I'll use parentheses I guess, 6 pi t. And y is always the same thing but sine. So y is 2 sine of 6 pi t. You know one, you know the other one. All right, perfect. So that's part B, we did that. Now part C is the tricky part. Now they want to know where the point B is. So A is just going around our circle, 3 circles per second, or 6 pi radians per second. But what is B doing? What is this point B doing? So a lot of times the trickiest part with these things is drawing the picture. So I'm going to make a right triangle, because that's always what you should do if you can, because we know how to do math with right triangles. So I'm going to drop a line down there, and this distance here is x, right? The x position at that point, we've been calling that x. That's what this is here. And let's call this, we don't want to use x again, so I'm going to call it d. So d is the distance between, so x goes to right here, and then d is the distance to the point B. So B Okay, so we have x and d. D is this length of our right triangle. And we'll just say the point B then is x plus d. Well, we have a formula for x. X is this. So all we need is a formula for d, and this is a right triangle. So we know that, oh, and this is y over here. The height is y, that point there, right? That's the height of this one is y. And the hypotenuse is 6 because the bar is 6 feet long. Feet long? Well, whatever unit it is. It's 6 long. So yeah, they're using 6. So all these things are in feet, so 6 feet long. Okay, so we just got to use the Pythagorean theorem to figure out what d is, and then we know what b is because b is x plus d. So I'm going to write all this down here. So b is x plus d, and from up here we know d squared plus y squared is 6 squared, Pythagorean theorem. So d squared plus y squared is equal to 6 squared, which of course is 36. We want to solve for d. So d squared is equal to 36 minus y squared, or d is square root, and it's a positive distance, so we don't need a plus or minus, we want a positive, so 36 minus y squared. All right, well, we know what y is, it's this. We know what x is, it's that, so now we just got to write it down. So our point B, the position of B, is x plus d. X is this, 2 cosine 6 pi t, plus d, and d is this, plus the square root of 36 minus y squared, so we have to square this thing, so that's just 4 sine squared of 6 pi t. And we're done. That's the point B. This is going to be negative sometimes. You know, this can only be positive. This is going to be negative sometimes, the x position. And so it's going to take away, and yeah. Okay, that wasn't too bad. Whenever you can, many problems, you got to make a right triangle out of it. And then you got to come up with letters. And you can call it whatever you want, but don't call them both x or something, and you know, that gets confusing. But that's often how you solve so many problems. You make a right triangle of it, because we know how we do math with right triangles. We can use trigonometry, sines, cosines, tangents. We can use the Pythagorean theorem. That's so often the way you solve things. Okay, then what's D? They're not done with us yet. D says, what is the x-coordinate of point B when t equals 1? You should be able to find it two ways. Oh, with your function and also using common sense. So t equals 1 second. At t equals 0, it's here. Let's see. It goes 3 revolutions per second. So in 1 second, it goes 3 times around. Oh, so yeah, in 1 second it goes 3 times around. So it's right here. So it's right there. It's right at the beginning point at 1 second, because it gets exactly 3 times around. So we know what the x-coordinate of B is at t equals 1. The x-coordinate of B is just 8, because that point's there, so it's 2 plus 6. So D must just be 8. So we could use our common sense for that one. Now we better, if we plug in 1 here, we better get 8. Let's see if that's the case. Actually, it looks pretty easy because we just have pi's. Alright, so let's do it. So t equals 1, we have cosine of 6 pi, which is the same as cosine of 2 pi, which is the same as cosine of 0, which is 1. Because cosine is the x value at t equals 0, the x value is 1. Then we multiply it by 2 here. So at t equals 1, this first thing is 2, plus the square root of 36 minus, okay, sine of 6 pi, sine here is 0, so that's all 0. Square root of 36 is 6, so 2 plus 6, which equals 8. Well, sure enough, there are 2 ways to do it. We could use our common sense, and we can plug in the formula. So either one works. Okay, now E says, is this thing here a sinusoidal function? Well, it has cosines and sines in it, so it's kind of sinusoidal-ish. But the book pretty much defines a sinusoidal function as our y is equal to a sine of, what is it, 2 pi over b times t minus c plus d. That is a sinusoidal function. This, you can't write this as that. They can't say put this in standard form. This part you can, no problem. We can write that as a sine because cosine is a sine shifted by 90 degrees by pi over 2. But this, you can't. So you would have to say, no, it's not a strict sinusoidal function. It can't be written in this form, even though it's got some sines and cosines in it. So, all right, that was 19.8. This is pretty fun stuff. Thanks for listening. Hope I didn't ruin the pleasure of solving this for you on your own. But, of course, you can always try it first. Okay, bye.